Hi everyone. So followed by the Cannizzaro reaction mechanism, we are going to look into the mechanism involved in the esterification reaction. See, when I come to the mechanism of an esterification reaction, the esterification reaction happens between an acid and then alcohol. So the reaction happens between a carboxylic acid and alcohol. The whole reaction will be catalyzed by an acid, so it could possibly be a concentrated sulfuric acid, or it can be a dry HCl, which is also the concentrated one. Okay, so the resultant product could probably be the ester with the elimination of a water molecule. So this is what happens with the reaction called esterification. So esterification is a very important reaction. See, it includes the reaction between the carboxylic acid and alcohol in the presence of a concentrated sulfuric acid, or you can use the dry HCl. With the elimination of a water molecule, the resultant product is an ester. Okay, so to look into the reaction mechanism, we need to proceed with the general reaction. The general reaction actually includes the reaction between, or you can take acetic acid, which is very clearly given in the textbook. Okay, you can take the acetic acid also, CH3, CO, OH, then C2H5OH. The whole reaction, as I said, the reaction is done in the presence of an acid. So hydrogen will take up the oxygen and goes as H2O. So a product is CH3, C double bond O, O, C2, H5. Okay, so the name of this is an acetic acid, or you can call it as an ethanoic acid. It is an ethyl alcohol, you can write it as an ethanol. So the name of the product is ethyl ethanoate, or you can write it as an ethyl acetate. So this is the general reaction involved in the mechanism of the Cannizzaro reaction. The mechanism actually includes the continuous steps, not like we have seen in the stepwise. Okay, you can write in the stepwise, need not to worry about it, but the step in it includes the number of a step. You have to write a number of steps, so you can write in a single sheet as much as possible. See, let me just begin with the mechanism includes. First, let me take the carboxylic acid, CH3, CO, OH. Since the reaction is done in the presence of an acid, the lone pair of electrons over the oxygen will be donated to the hydrogen, thereby a new bond is formed between oxygen and hydrogen. So CH3, C, double bond O, H. Since oxygen has donated an electron, we will get a charge of plus over it, and again we have got OH. So this is the very first step. The second step includes the attack of this ethanol. Ethanol is C2H5OH. Okay, so lone pair, lone pairs. So oxygen will donate a lone pair of electron to the carbon, thereby a bond is formed between oxygen and the carbon. Since a bond is formed between oxygen and the carbon, the valency of the carbon becomes 5. So this bond will actually shift and exist as a lone pair over the oxygen. So to begin with, CH3, C, OH. So bond pair again turns into a lone pairs. Then we have got O, H, C2, H5. Since this oxygen has donated an electron, here this oxygen will get a charge of plus. On the right side we have got OH there. Okay, right. The next step includes the cleavage of the H plus ion. The hydrogen which is present here will go out, thereby this bond will shift as a lone pair over the oxygen. So minus H plus. So we'll be getting CH3, C, O, H, Okay, then we have got OH, then here we have got OC2H5 since hydrogen have gone out. The hydrogen which has gone out will not go anywhere, will remain within the reaction mixture itself. So again this oxygen will donate a pair of an electron to the hydrogen, then it will abstract the hydrogen, which results in the formation of CH3, COH, H. Since oxygen has donated electron, it will get a charge of plus. To the right side we have got OH, then we have got O, then we have got C2H5. Okay. Even if I didn't mention the lone pair of an electron, when the oxygen is surrounded by two bond, it will have a two pairs of an electron over it. Then the next step includes actually this bond will shift and form a double bond between carbon and the oxygen, thereby the whole thing will goes as H2O. So H2O molecule goes out. Okay, so CH3, C, double bond O, then C2H5. Here you will get a charge of plus since oxygen has donated electron. On the right side we have got OH. Okay. Then the next step actually includes the C2H5OH or otherwise the hydrogen which we have taken in the very first step has to be given to the acid itself. So hydrogen will goes as H plus. Okay. So this hydrogen goes as H plus, this bond will shift here, thereby a double bond is formed with the carbon and oxygen, valency of the carbon turns 5, so this bond will shift and exist as a lone pair. Okay, so H hydrogen ion goes out. So a product is to start with CH3, C, double bond O, O, C2, H5. So as a ester is a product. Okay. So the whole thing happens in consecutively, so it is better to enclose in this way, instead writing it as a step by step. The very first step is protonation. When it gets protonated, the second step happens with the attack of an alcohol. When an alcohol attacks, which results in the formation of a bond between the alcoholic oxygen and the carbon, then followed by hydrogen ion goes out. So this bond will exist as a lone pair, and finally the hydrogen which just goes out doesn't goes anywhere, it stays within the solution. So oxygen will donate a pair of an electron, so by taking the hydrogen, so oxygen will get a charge of plus. Then immediately the oxygen which is present in the alcoholic carbon will be donates and a pair of an electron to the carbon, thereby H2O goes out. Then when H2O goes out, the proton that has been donated in the very first step will be taken up by the acid itself, or we have to give it back to the acid. So when H plus goes out, which results in the formation of an ester. So this is what regarding the mechanism of the esterification. See, as I said, this mechanism of an esterification includes the reaction between the carboxylic acid and an alcohol in the presence of concentrated sulfuric acid, or you can take a dry HCl, the resultant product is an ester, then water molecule will get as a byproduct. Then we will take an acetic acid, then ethanol, so water molecule goes out, which results in the formation of an ester. So to end with the mechanism, we have seen it very much clearly. You can take a look at it and you can have a note of it. If you have any doubt, you can let me know in the comment box below. Okay, the mechanism of further the content and the very important reactions involved in this organic chemistry and rest of the things will be dealt shortly. Then followed by, if you have any queries or if you have a request to be done so that you can able to look into it whenever you wish to have, you can let me down in the comments box below. See you all in the next session. Thank you.